Hello, my dear automata students. So I'll begin to discuss here another topic, another set of topic, which we will begin to work on, which is cleaning up context-free grammars, or also known as the context-free grammar simplification. So actually, it is really important to simplify context-free languages that we do have. This is really the steps that we have to consider before we will begin to apply work on with the Chomsky uh, normal form, the grayback thing. So we'll begin to work on that as well in the future. So here then, cleaning up context-free grammar, let's start. Cleaning up the context-free grammar, or the CFG simplification, focuses on removing unnecessary production while preserving the original language. And that is actually the foundational procedure used before transforming grammars into normal form. So this is really necessary in terms of improving improving your steps, improving or strengthening your language. This is really a must. So next will be cleaning the CFG will really ensures that only meaningful rules remain in the grammar. This makes the grammar easier to analyze, transform, and use in parsing technique or algorithm. So what does that mean? So because there will be a set of production rules wherein a little bit of tricky, a little bit of redundant. So what we are trying to work on is we are trying to solve those thing which is production rule which is redundant. Those are the um, cases that we will be going to solve in this criterion. Now, raw grammars often contain symbols that never produce terminal strings or can never be reached from the start symbol, and these unnecessary structures complicate derivations and increase the complexity of grammar's transformation. So since we are trying to optimize the functions also, and especially complexities, and we are trying to observe those simplification so that those item which is especially if there will be um, useless symbol or productions, we can definitely solve that as we go through with the process because there will be three methods or three simplification ways that we will begin to perform in simplifying the context-free grammar. So here then, simplifying a context-free grammar, meaning eliminating null production, unit production, and symbols that do not contribute to the terminal derivation. And the goal is to keep only the rules that help generate strings of the language. So what we are trying to strengthen here that we will be going to um, observe actually those production rule which will achieve the specific criterion that you are the goal which could somewhat achieve the goal that you may possibly wanted to do. That's actually the goal here then. So since redundancy, ambiguity is one of the problem in terms of context-free grammars, we're trying to normalize those structures here. And there will be three main simplification components. The three consisting of the major task, reduction of the context-free grammar will be the first method, and then second will be removal of unit production and removal of the null productions. So we'll begin to work on that step by step, of course. These actually tasks are applied in an organized sequence to avoid reintroducing the problems. So this will really a big aid for us to strengthen those like a language that you do have will basically be improved. Now, why we need to simplify the context-free grammar? Of course, that is really necessary. Many grammars contain symbols or rules that do not contribute to the derivation of strings, so we're in useless. Simplifying will ensures that only variables and rules that lead to terminal strings remain, making the grammar easier to work with. So, we are trying to observe that those useful um like the terminal or non-terminal will be focused in this state. And if those useless productions, those null production on those symbol, we will begin to remove those cases if ever that they are not definitely useful anymore as we run through with the process. But no to worry, we will begin to work on that step by step. So nevertheless, we will begin to work on um, with those cases, those three methods, step by step in another video also so that it will be we will begin to clear out things. And there are advantages of cleaning the context-free grammar as we will go through the process. Cleaning a CFG, the context-free grammar will basically um, the remove the unnecessary complexity, improving both clarity and performance, and a simplified grammar is easier to analyze, parse, and transform into standardized forms than like the Chomsky normal form or Rybak normal form, making it essential for both theoretical studies and practical application. So that means to say, we're trying to simplify, we're trying to remove those useless, it could be production, those symbols, or those items, or the null productions. Those are the cases that we are trying to observe, to omit, in order for us to have it simplified, and we will just focus into those useful symbols, especially for the terminal and non-terminal symbols. Now, the disadvantage of cleaning this context-free grammar while simplifying those CFG will make it more efficient. The process can sometimes lead to an increase in the number of production, particularly when dealing with null production. Additionally, simplification doesn't always result in the smallest possible grammar, and some complexity may still remain. So since we're trying to simplify everything, we're trying to, of course, have it deterministic. So observe or expect that the production or the rules, production rules will be basically the many of possible things that possible symbols that we can definitely have as we run through with the process, particularly in every method we'll begin to run through in that actually, since this is really important in terms of studying context, in terms of studying those kind of cases like the Chomsky and Breibach. You have to simplify you have to normalize your to fully determine those cases. So that's why this is really important to observe. Okay. Now the application, where can we apply the CFG simplification? It is crucial in compiler design, where a cleaner grammar is required for efficient parsing and code generation. Of course, if that is deterministic, it is really easy to simplify. So and that is required for actually, so that um You will not begin to have a bunch of modification, improvement, or normalization, for example. It also plays an essential role in theoretical computer science, such as, yeah, we all know the automata theory, by providing a foundation for proving properties about the languages. So hopefully that you were able to understand what will be the importance pertains to this, but I'll begin to illustrate in a while also. Um, I'll begin to work on um, per steps or per method in separate videos. So see you there. So make sure to really what will be your sentiment, especially for this topic. This is actually convertible to a specific points. Make sure to definitely leave a comment to strengthen, I mean, in order for me to know that you're able to understand the process. Okay. Now, see you in the next video class and goodbye.